we are going to learn about what are called parametric constraints. And we're going to do that by looking at this very simple rectangle. Now, this rectangle has a height of 2 and a length of 4. These are called numeric constraints, and that makes sense, doesn't it? I'm constraining the size of this line to be 2 inches by typing in the number 2. The disadvantage of this is if I want to scale this down to a smaller size and I want to keep the relationship between the height and the length the same, let's say I want to scale this down to 1 inch. Well, if I'm going to scale the part, I'd have to make this 2 inches. In other words, I would have to cut each one down by half. There is a way for me to write the relationship of this length in terms of what the height is. Now, we know that the length in this particular example is 2 times the height. So that's called parametric constraints. In order to do that, we have to understand that each one of these dimensions has a name. And to find that name, I simply click on the dimension and we can see this dimension's name is D0. This dimension here, the height, is D0. This dimension is D2. And what doesn't really matter what it's called, it's just the name of that particular dimension, and the computer assigns what the dimension should be. I don't know where D1 is. I would think that this should be D1, but for some reason it's called D2. It's not a big deal. All right, so if we want this length to be twice as big as the height, no matter what changes I make to the height, then I can do a parametric equation in the length dimension, and I would do that by typing in the algebraic equation 2 times the height, and the height is not 1, it's D0. So we put in an equation, D0 times 2, that defines the relationship between the length and the height. And now if I change this to 2 inches, the length will automatically change to 4. If I change this to 3 inches, it will automatically change to 6. That is a parametric constraint. Now, you'll notice here that it says fx in front of the 6. The fx is a function. It tells you that that is an equation inside there. What if I wanted the length to be 1/3 the height? Very simple. I'd come in here and I could type in, instead of 2 times D0, I would say D0 divided by 2. And now, sorry, I want it to be 3, right? 1/3 the height. D0 divided by 3. So if the height is D0 and it's divided by 3 and the value is 3, this is going to be 1, isn't it? There it is, 1. So this is a parametric equation. Now, we need to be careful when doing parametric equations because you have to keep in mind the order of operation. For example, if I type in D0 divided by 3 times 2. Oops, the times is shift 8. D0 divided by 3 times 2. Now, what it's going to do, it's going to divide D0 by 6. It actually didn't do that, did it? What it did is it took the D0 divided by 3 and then multiplied the entire thing by 2. But what if I wanted it to be, what if I intended it to be D0 divided by 6? Well, I need to put this in parentheses. I would put this into parentheses, the denominator, because we have to keep in mind the order of operation. That's not going to work. Divided by 3 times 2. Parentheses. There we go. D0 divided by 3 times 2. And now we'd end up that it would be D0 divided by 6. So we have to keep in mind the order of operation. Okay. In this assignment that you're going to have, this activity 8.2, what it's asking you to do, to study the images and table on the next pages. Use the given information to create the missing parametric equations and to calculate the missing values. All right, as we come down here, here's a plate with a slot and a hole. Okay? It gives you the names of the variables. It gives you some other variables that are not shown here, but it tells you what they are. So D3 is the plate taper angle. So when you do your extrusion of the plate, you're going to have to put a taper angle in. You know how to do that. That's called D3. Now, as we come down here, we see this, and this was confusing to me. That's why I'm explaining it to you. As we're looking at this page here, it's showing you how to make the part. You draw the rectangle, and you put in the dimensions for the width and the height. You come here, this is your extrusion. You put in dimensions for that and for the taper angle. Don't forget the taper angle. You come over here, you make the slot, and you put the dimensions in that it shows you. Okay, so you're going to be making the part using parametric equations. What equations are you going to use? Well, you're going to come down here to this table and fill this out. So, for example, they're telling you that D3, which is the overall plate depth, is 3 inches. Okay? You do not need to find any relationship or parametric equation. As a matter of fact, all the relationships are given. You're simply going to be finding the equation and the value. So if we come over here to D2, it says D2 is the plate thickness. The geometric relationship is that it's 20 times smaller than the overall width. Okay, where is the overall width? The overall width is here. Its dimension is D1. This is 20 times smaller than the overall width. So what would this be? 20 times smaller than the overall width. It's going to be D1 divided by 20. D1 divided by 20. And you would type that in, and that's a small d, not a capital D. D1 divided by 20. It's 20 times smaller than the overall width. Now, what would the value be? Okay, here's where you need to put in some, you can either figure it out. You're going to need to figure it out here. If D1, which is the overall width, is, and they give you the equation, 5/3 times D0. If I plug in a 3, right? I plug in a 3 here for D0 because D0's value is 3. I plug a 3 in. 3 times 5 divided by 3 is 5. So D1's value is 5. And that's inches. It's 5 inches. So if I then plug 5 into D1, into the parametric equation for D2, then it's going to be 5 divided by 20, which is, what's 5 divided by 20? 5 divided by 20 is 0.25. Right? 1/4. 0.25 inches. There you go. So that is how you're going to complete this assignment. It gives you the relationship. Now you're not going to type in to the plate, you're not going to type in these values. You're going to type in these parametric equations in for the dimensions. Okay? I hope you understand that. You're going to actually be making the part, save it, and you're going to be uploading something. You look at the parametric equation upload below this particular lesson to see what you're supposed to upload. Okay?